Okay, here's the second video that we did for in-class practice for differentiation. So again, this is still on page 142. And again, I want to remind you that you can graph this and find the answer right off the bat, and I'll show you that at the end. So I just wanted to remind you that you could do that. I showed you this on the last video. Now this one says, find the slope of the tangent line to the curve at the point where x equals a. And then it says, find the equation of the tangent line at the point 1, 1. I personally, I can't even talk today, personally would just find it when x equals 1. So you're actually going to, again, use when x is 1 right into the formula right off the bat so that you're not doing more work than you need to, because after they said that, they said graph the curve and the tangent line. So we're going to do what we did on the last one. So I'm going to do f prime of 1, because that's what they ask us to. They didn't ask us for anything else, is the limit as h approaches 0. Now I'm actually going to plug the 1 plus h again into the formula. So it's going to be 1 over radical 1 plus h minus 1 over radical 1, which is what that is, okay, all over h. Now I want to show you something that I didn't really need to do 1 over radical 1, because this is what I said in the last one. If x is 1, I know that f of 1 is 1 because the point 1, 1 is on the graph. So really, I could have just called this 1 right off the bat. So I just want you guys to see that if they tell you the point, your life is good. So that's really just a 1. And now what I'm going to do is, it's a complex fraction, so I'm going to multiply the numerator and the denominator, and I'm trying to find a different color, by the common denominator. Ooh, Christmas. So I'm going to multiply them all by radical 1 plus h, radical 1 plus h, radical 1 plus h. So this is going to equal the limit as h approaches 0 of 1 minus radical 1 plus h, because I'm going to multiply that by 1, all over h, radical 1 plus h. Now this should be getting, okay, a little familiar for you now to see that, oh, I know what to do here now. I can multiply this by the conjugate, and the conjugate of the numerator, because you're basically rationalizing the numerator. So I've got 1 plus radical 1 plus h, all over 1 plus radical 1 plus h. And when I do that, I have a beautiful, nice thing here. We're going to come back on this line, say f prime of 1 is the limit as h approaches 0. And remember, when you're multiplying these out, the numerator is going to look really pretty, except don't forget it's going to be 1 minus, to put the 1 plus h in parentheses, or this is going to not come out right. And the denominator is ugly, but we're going to leave it. Remember, don't multiply it out. Don't forget the denominator. I've always had someone do that, all right? So now, after I've got this, I said, okay, that equals the limit as h approaches 0, and I'm going to distribute that negative right here. So it's going to be 1 minus h all over h, radical 1 plus h, parentheses 1 plus radical 1 plus h. And I can say, thanks for playing. And even right here, you can look at it. I can say, oh, I bet you now I can get rid of the h. So we're going to do that on the next line. The limit as h approaches 0, I have a negative h all over h radical 1 plus h, parentheses 1 plus radical 1 plus h. And now I can say, thanks for playing, that's a negative 1. It's the limit as h approaches 0 of negative 1 all over radical 1 plus h, parentheses 1 plus radical 1 plus h. And I'll see now where I can start plugging my 0 in, because I got a negative 1 on the top, so I know I'm coming near the end. So I'm going to do f prime of 1. I don't have to write limit anymore, because I'm literally going to plug in the 0 right now for h. And if I look at that, that's negative 1, and this right here is a 1. The square root of 1 is 1, and this is 1 plus 1, so this is 2 for this one together, so it's going to be negative 1/2. So I know that the slope when x is 1 is negative 1/2. Now we're going to do the tangent line. So I'm going to do y minus y1 equals mx minus x1. And I'm going to plug in the negative 1/2 right here. And I know the point is 1, 1. So I'm going to do y minus 1 equals this, x minus 1. And then I would be happy if you left it like this, negative 1/2 times x minus 1, and bring over that 1. So that one is fine. Or you can keep multiplying that all out. And if you did, you'd have y equals negative 1/2 x plus 1/2 plus 1, which would come out to be y equals, what's negative 1/2, sorry? Negative 1/2 x plus 3/2 or 1/2. So either one's fine. But again, the reason why this one is good is because I can check it on my calculator. So I graphed it. So here's my calculator. I'm going to come over to the graph. Here is 1 over radical x. They asked us to find the slope at 1. So again, menu. You're going to analyze graph, and you're going to use dy dx. And I'm just going to type a 1 in, hit enter, and there is my slope at 1, which is negative 1/2. Isn't that wonderful? Now we're going to do menu, geometry, points and lines, and I'm going to do a tangent. And I'm going to hit right there. And there we go. There's a 1/2 x, negative 1/2 x plus 1/2. I don't know if I can move it down here. There we go. There is our tangent line. So I actually in class had the students do this first and said, okay, we already know the answer. Let's make sure that our algebra that we did on this page all justifies it. I don't mind it. Oh, that's pretty. So that's the end of this video. I'm going to do one more for the next one, number 4.